How do these materials compare to other types of anode materials in terms of their suitability for sodium-ion storage? What happens during the first charging process of sodium-ion batteries, especially when carbon materials are used as anode materials, and why does electrolyte reduction occur on the surface of the anode? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does this electrolyte reduction lead to the deposition of insoluble sodium salts, and what role do these salts play in the formation of the solid electrolyte interface SEI film? What are the key characteristics of the SEI film, and how does it allow sodium ions to move in while preventing the passage of solvent molecules? How does the SEI film contribute to the isolation of the electrode from the electrolyte when it reaches a certain thickness? What impact does the electronic insulation provided by the SEI film have on the reduction reaction of the electrolyte, and why does this stop the irreversible reaction caused by electrolyte decomposition? In what way does the formation of the SEI film contribute to the stability and reversibility of the battery during subsequent cycles? How does the formation of the SEI film lead to the generation of a large amount of irreversible capacity during the first cycle? And why is this capacity loss significant in terms of the long-term performance of the battery? Why can't the lost capacity from the first cycle be recovered in subsequent cycles? And how does this affect the actual capacity of the battery? What are the ideal properties that sodium-ion anode materials should possess to ensure both stable thermodynamic performance and compatibility with the electrolyte? And how do these properties influence the formation of a good SEI film? Why is it important for the anode material not to react with the electrolyte after the SEI film has formed, and how does this prevent further irreversible reactions that could degrade the battery's performance? How is the electrolyte in sodium-ion batteries composed, and what are the main components of the electrolyte? How does the electrolyte salt, typically sodium salt, affect the performance of the electrolyte, especially in terms of solubility in the solvent? How does the solubility of sodium salt in the solvent influence the number of carriers in the electrolyte, and why is this important for the overall efficiency of the battery? What role does the redox potential of sodium salt play in determining the electrochemical window of the electrolyte system, and how does this impact the battery's performance? How do the chemical properties of the anions and cations in sodium salt influence the stability of the separator, solvent, electrode, and fluid collector in sodium-ion batteries?